We know that the vertex is a special point on a parabola because if you remember, there's a line of symmetry that runs right through the center of the vertex and divides the parabola in two. We saw that tangent lines on opposite sides of the parabola at the same vertical position have opposite slopes. In other words, if we folded this parabola in half down this dotted line, the two halves it's divided into right now would match one another perfectly. But let's see if we can make any other general statements about the behavior of the function on this side of the graph versus on this side of the graph. For a moment, let's just look at this right half. The coordinates of our vertex, as I showed you in the last problem, were negative 0.75 and negative 2.25. So for now, we're just going to only consider the domain in the region where x is greater than negative 0.75. As you can tell, on the right side of the graph, as x gets bigger, f of x gets bigger as well. So I'd like you to complete this sentence properly. On the interval of the domain from negative 0.75 to infinity, so in other words, this half of the graph we've been talking about, what is happening to the value of the function? Is f of x increasing, decreasing, or constant? So remember that we read graphs from left to right. So this is asking what is happening to the behavior of f of x, of the value of the function, the dependent variable, as the independent variable x increases.